Okay, you're given this equation of an implicitly defined relation, which does in fact happen to be a hyperbola. Here's the graph in blue, and you're asked to find the equation of the tangent line at the point where x is 5 and y is 3. Here I've confirmed that the point 5, 3 actually does lie on the graph. And we're going to find the equation. I'm implicit differentiation. It's actually possible to solve this for y using the quadratic formula, but we'll do it implicitly. So the derivative of the first term with respect to x is 2x. Here we have to use the product rule. So it's the derivative of the first, which I'll call the first function negative x and the second function y. So the derivative of the first is negative 1 times the second. And then it's the first function minus x times the derivative of the second. And then for negative y squared, use the power rule, 2y. Since y is a function of x, we have to employ the chain rule. So the derivative of y, with respect to x, you could say dy dx, or you could say just y prime. And now what we're going to do is factor out a y prime from these two terms. And we're going to transpose the other two terms to the right side of the equal sign, changing their signs. We factor out that y prime. To isolate y prime, we divide both sides by the coefficient, which is this negative x minus 2y. And if you don't like leading negative signs, you can multiply numerator and denominator by negative 1. And there's a formula for the first derivative in terms of x and y. If you plug in 5 for x and 3 for y, you get 7/11, which is the equation as the slope of the tangent line at that point. Notice also way back here, you could have substituted 5 for x and 3 for y and solved for y prime directly. You didn't have to go through all this, but if you wanted to find the derivative or the slope at other points, it might be good to have a formula. Okay, and so now we use point slope, y minus 3 equals 7/11 times x minus 5. You could remove the parentheses, add 3 to both sides, and get slope-intercept form. And just so you can see some cool things you can do on Desmos, here is the graph of that tangent line at the point 5, 3. But here are some functions that define that same function in terms of x. So I use the quadratic formula, put them in a list for big F. And there's big F, and then if x of 1 is a number, I can graph both tangent lines at both points where x is equal to 5. In this case, if I use a slider on x of 1, you can see that every x value that's in the domain of the hyperbola has 2 tangent lines. There you go. Hope that helped. If you have any questions, post a comment.